In October 2017, a telescope in Hawaii detected something moving through our solar system. At first, astronomers thought it was a comet, then a strange asteroid. Then they calculated its speed and its trajectory, and something was deeply wrong. This object had not come from our solar system. It had come from somewhere else entirely. It had traveled between the stars for millions of years, and for reasons nobody can explain, it passed directly through our solar system, accelerated as it left, and vanished into the dark. No one knows what it was. The Harvard astronomer who studied it most closely still believes it may not be natural. This is the story of Oumuamua. On October 19th, 2017, astronomer Robert Warwick was reviewing images from the Pan-STARRS telescope at the Haleakala Observatory in Hawaii. The telescope was part of a survey program, scanning the sky for near-Earth objects, things that might hit us. He spotted something moving, fast, unusually fast. He flagged it. Other astronomers looked, and within days, something became very clear. The object's path through our solar system was hyperbolic. That word, hyperbolic, is everything. Objects that belong to our solar system travel in ellipses, ovals. They loop around the sun and come back. Comets do this. Asteroids do this. Everything we've ever found does this. A hyperbolic trajectory means the object is moving too fast to be captured by the sun's gravity. It's just passing through. It came from somewhere else, and it's going back to somewhere else. Scientists immediately understood the significance. This was the first interstellar object ever detected passing through our solar system. They named it Oumuamua. In Hawaiian, it means scout or messenger from afar, arriving first. And here's the first thing that should bother you. By the time we found it, it was already leaving. We had a matter of weeks to observe something that had traveled millions of years to get here, and we almost missed it completely. As telescopes around the world scrambled to observe Oumuamua before it disappeared, the data coming back was deeply strange. The object's brightness kept changing dramatically in a regular rhythm. Every 7.3 hours, it got dramatically brighter, then dimmer, then bright again. When astronomers modeled what could cause that kind of light variation, they came to a conclusion that stopped them cold. Oumuamua was not shaped like anything we had seen before. The most likely explanation from the brightness data was that it was either extremely elongated, like a cigar, or extremely flat, like a pancake. We're talking about object potentially 10 times longer than it is wide, or a disk so thin relative to its diameter it would be unlike any asteroid or comet ever catalogued. Interstellar rocks don't usually look like that. The forces of space, billions of years of collisions, gravity, radiation, tend to create roughly rounded objects. Not perfectly shaped cigars, not razor-thin discs, but that wasn't the strangest part. In the weeks following its discovery, scientists tracked Oumuamua as it swung around the sun and began heading back out toward interstellar space. And as it moved further away from the sun, they noticed something that had no explanation. It was speeding up, not by a little, by a measurable, consistent, undeniable amount, more than the sun's gravity, more than the gravitational pull of any planet could account for. Something was pushing it. When a comet accelerates unexpectedly, we know why. It's outgassing. Frozen materials on its surface heated by the sun, vaporizing and releasing jets of gas that act like tiny thrusters. It's called non-gravitational acceleration, and we've seen it thousands of times. So astronomers looked for the same thing on Oumuamua. No gas, no dust, no trail, no coma. The cloudy envelope that surrounds most comets near the sun. Nothing. The object was accelerating with no visible means of propulsion. The excess acceleration was 6 times what solar radiation pressure alone could explain, based on the object's estimated mass. Some researchers propose that outgassing could still be happening, just from hydrogen, which is invisible to our telescopes. Others weren't satisfied, because here is what you have to understand. Every explanation that works for the acceleration creates a new problem somewhere else, and the problems keep stacking up. In 2018, Harvard astrophysicist Avi Loeb published a paper that caused a firestorm in the scientific community. His argument, written with co-author Shmuel Bialy, was carefully worded, scientific, mathematical. It said this: if you take Oumuamua's observed acceleration and you try to explain it with solar radiation pressure, which is the gentle push that photons of sunlight exert on objects, you have to conclude the object must be extremely thin and extremely light, specifically a flat, thin sheet, less than a millimeter thick, but potentially hundreds of meters across, like a sail. And then Loeb asked the question that most scientists refuse to ask. What if it was? What if Oumuamua was a light sail, a spacecraft designed to be propelled by stellar radiation, drifting through interstellar space, no longer under anyone's control? The scientific community's reaction was immediate and largely hostile. The consensus was that extraordinary claims require extraordinary evidence, and there was no evidence of artificial origin. But Loeb pushed back. He argued that refusing to consider the possibility was not science, it was dogma. He pointed out that we dismiss the artificial hypothesis, not because we have evidence against it, but because we are psychologically uncomfortable with what it would mean. And he noted something that has stayed with him since. If Oumuamua had arrived 50 years earlier, before we had the instruments to detect it, it would have passed through completely unnoticed. How many others have we missed? Here is what the data confirms without any interpretation. Oumuamua was the first interstellar object ever detected passing through our solar system. Its trajectory was definitively hyperbolic. It did not originate here. Its shape was unlike any natural object previously observed. It accelerated beyond what gravity and known forces can fully explain. It produced no gas, no dust, no tail, eliminating the most common explanation for unexpected acceleration. It is now gone, permanently, moving at roughly 26 kilometers per second relative to the sun. No spacecraft we have could catch it. The scientific community has not reached a consensus. Multiple hypotheses exist. None of them fully satisfy all the data. Hydrogen iceberg, nitrogen fragment, fractal dust get to aggregate, light sail, all of them solve one problem and create another. What is not in dispute is this: something came here from another star system. It behaved in ways we cannot fully explain, and we watched it leave. We are, by the laws of physics, almost certainly not the only life in a universe containing 2 trillion galaxies, and we have exactly one confirmed visitor from interstellar space. One, and we don't know what it was. In 2023, astronomers detected a second interstellar object passing through our solar system. It was named Borisov. Borisov behaved like a normal comet. Gas trails, predictable movement, no mysteries. It looked exactly like what we expected, which makes Oumuamua stranger, not less strange, because now we have a comparison. We know what a normal interstellar object looks like, and Oumuamua was not it. If you want to know what I think happened, subscribe, because the next video goes somewhere even darker